Good evening, everyone. A warm welcome to today's AWS Architecture Masterclass, proudly organized by the FOSS Community, University of Kelaniya. It's fantastic to see so many of you joining us for what promises to be a power-packed session on cloud architecture and AWS best practices. In today's world, cloud computing is at the heart of digital transformation, and mastering AWS architecture is a game changer. Whether you are a developer, cloud enthusiast, or aspiring architect, understanding how to design scalable, cost effective, and resilient cloud solution is essential. We are thrilled to have a seasoned expert with us today, ready to share valuable insights and real world AWS strategies to level up your cloud skills. Before we dive in, let's go over few housekeeping rules to ensure a smooth session. Keep your microphones muted and turn off your camera during the presentation to minimize disruptions. Drop your questions in the chat at any time. We will address them during the Q&A session. This session is being recorded, so you can revisit key takeaways later. Now it's time to introduce our esteemed speaker, Diliru Munasingha. We are honored to have Diliru Munasingha, Senior Software Engineer at Ascentic, with us today. Diliru is an expert in cloud solutions, AWS architecture, and software engineering, specializing in designing scalable, cost-efficient, and highly available cloud infrastructures. With extensive experience in cloud security and automation, he has played a vital role in helping businesses optimize their AWS ecosystems. With his technical knowledge and hands-on experience, Diliru is here to guide us through the fundamentals and advanced concepts of AWS architecture. Whether you are just starting or looking to enhance your cloud expertise, this session will improve. This session will provide you with proven strategies to think like an AWS architect. So get ready to learn best practices, industry insights, and expert techniques to optimize your AWS solutions. Without further ado, let's welcome Diliru Munasingha. Diliru, over to you.
Yeah, thank you, Agisha. Hi guys, good evening. So I'm Diliru Munasingha, and right now I'm working as a senior software engineer at Ascentic, and we are like working over 5 years with AWS now. So yeah, I'm excited to share some insight with you guys about AWS and how to build a cost optimized solution with scalable architectures. Yeah, let me share my screen. Hope you guys can see my screen. All right. Good. Yeah, so for today's session, we are talking about thinking AWS, and with that, we are trying to discuss about how to make scalable and cost-effective architectures. All right. So let's start with the question. So, how many of you guys have been using AWS in your like day-to-day work? Maybe you can put a message on chat or unmute yourself, or in that case, the Q&As, you can put some answers. All right. Yeah, so I only see one person who's been using AWS. So let me rephrase that. How many has been using Netflix for your like watching TV series and movies? Yeah. So I see most of you guys have been using Netflix for your like watching movies and streaming TV series and so on. So which means indirectly you guys have been using AWS as well. So let's dive more into that, how industry uses AWS and real world scenarios in this session. So let's go for the outline of the session. So first we're gonna go through AWS and cloud economics and the science of scaling and the AWS architecture in action, cost optimization, and finally a Q&A session. Okay. So let's first move on to AWS and cloud economics. So AWS stands for Amazon Web Services. And if we take a look at how this has been developed, this has been developed as an in-house product for Amazon company. So they have a huge e-commerce platform. So to accommodate that, they have been using their in-house infrastructure in order to maintain and scale their applications. So what they have basically done is like they have built a very good system with that, and they rent it out to third parties to use that as a service. That's why we called Amazon Web Services. All right. So then we have another question. So what do Netflix, Airbnb, NASA, and McDonald's have in common? Maybe you can use that Q&A forum to answer this. So I like to keep this interactive as possible. Yeah. So anyone got some answers, please put them in the chat. All right. I think no one has the answers. All right, this one. Yeah, they have websites. Yeah, that's one answer. Can we have some other answers? Yeah, all are top companies. Yeah, exactly correct. So, what do all of them are like share commonly? Yeah. So among all the other things, what do have they share commonly is all of them have been using AWS in part of their system or in the whole system in order to cater for mass audiences. So these names are like tech giants like Netflix, Airbnb, they all are billion-dollar companies. And NASA, it's a mission critical company. And McDonald's, same. So all of them has been using AWS as for their preferred infrastructure choice in order to make sure they can cater into mass crowds. Right. So that is something like they all do share. So with that in mind, let's go to our next slide. So why do these giant companies, these huge companies choose AWS? Uh, we can like break down these two main three things. Like AWS has pay as you go pricing model. So even you are a startup or a very large company, you don't have to like pay upfront for infrastructure. And they also have a global infrastructure, like over 30 plus countries, over 100 plus availability zones. They have a huge infrastructure. And when it comes to the maintenance, uh, we do not have a maintenance hassle, which can occur in in-premises infrastructures. So they basically give solutions to these three steps. So that's why most of these companies choose AWS. But the awesome thing is these huge companies are using the same technologies or same building blocks which we can use to build our applications as well. That's the most awesome thing about AWS. All right. So let's go to talk about how AWS powers different industries. So before moving to architectural part, I think it is essential to understand what a great tool we have in our hand and how we can use in different kind of scenarios. When it comes to Netflix, it's a streaming platform. So let's say new Stranger Things series dropped out or Squid Games dropped out, the streaming session is going very high up, like 100 million plus streamers at once. So they need to cater to those massive spikes of usage. Same with the Airbnb. So Airbnb is a booking system as we know. But when it comes to peak travel times, they are like normal usage spike up to 300%. So put it into numbers. Like if usually Airbnb has 1,000 users daily, in the peak traveling times, it spike up to 3,000 users per day. So they need to keep up with those usage spikes. So in order to do that, they are massively leveraging AWS scalable approaches. And when it comes to NASA, so NASA is also using AWS for what? So as you know, NASA have a huge number of satellites in their hand, and those satellites constantly sending petabytes of data. So they need to analyze their data. Instead of doing that in premises infrastructure, what they have done is like have used AWS SageMakers and all other services in order to analyze those data. And we have McDonald's in that. So McDonald's is a fast food chain, as we all know. But why such a chain need AWS? So right now we are in an AI bubble. So McDonald's is using AWS SageMaker to make SageMaker to train their AI models. So what they have basically doing is like when we are going to a drive-through window, McDonald's use a system to predict what's that user gonna order from that drive-through window. So for that, they are generating AI models. Same goes for Uber for like handling massive usages and handling those geometric data. They have been leveraging AWS as well. So same as they do, we do have the same kind of tool sets to build our own applications. That's why it is essential to understand the architectural approaches in order to make sure we are leveraging properly from those tools. All right. Yeah. So let's go to the second part of the discussion, the science of scale. So as from the beginning of the discussion, I said scalability a couple of times. So that is the massive selling point for AWS. So something we cannot do in our in-premises service is the scalability. So AWS is like having the scalability option is like unlimited. If you are using a Lambda functions or Fargate, you have virtually like unlimited scalability in hand. So that's a really awesome thing with AWS. So there are two type of scalability we can talk about. So can someone put a message or something like that in the chat? What are the two type of scalability when we are talking about infrastructures and these cloud services? Yeah, exactly. Horizontal and vertical. And what is the difference between those two? Yeah. If you want to unmute your mic, it's also fine for. Yeah. All right. Let's go to the differences between horizontal and vertical scalabilities. So when it comes to horizontal and scalabilities, vertical scaling is called scale up, and horizontal scaling is called scale out. Why we call this that? So when we talk about vertical scalability, it means we have a single server and we are adding more CPU, more RAM into that server. So let's say you have a computer and you need more processing powers. You simply put more RAMs, more CPUs, or in that case, more memory into that server. And when it comes to horizontal scaling, it's rather than like upgrading that single server, putting another server and distribute the load. So you have a one computer. If the one computer cannot hold that load, you simply gonna add another server. So when we talk about good architectures in AWS, it's mostly horizontal scaling. Why it is mostly horizontal scaling? So if we talk about vertical scaling, it requires a downtime. Let's say you are getting a dedicated server. You can do that with the AWS. You can get an EC2 and you need to upgrade like your machine hits its limit. So you're gonna upgrade that EC2. In order to do that, you need to shut down the server and restart it again without with added resources. But then there's a problem. If it is a mission critical system, let's say a hospital system, or in that case, Netflix as well, it's gonna have some kind of a downtime. So with good architectures, AWS infrastructures are prioritizing horizontal scaling rather than scaling up, like upgrading the resource itself. It is adding more resources and downgrading more resources accordingly. So that's a like a trademark of and good architecture. So you probably prioritizing horizontal scaling and like adding more instances, distribute load. So all Netflix, Uber, Airbnb, all of them are leveraging this architecture. So with that in mind, there is another concept we should understand when we try to build a good architecture in the AWS. So that is difference between scalability and elasticity. Yeah. So yeah, and I see an answer like also vertical scale need upfront costs. Yeah, that exactly. That's another drawback of the vertical scaling. So can some of you send me some answers? What is the difference between scalability and elasticity? All right. Let's move to that slide as well. So as a good architecture, it should implement elasticity rather than scalability. Why is that? Let's go to the next slide and see what's what. So scalability means the system itself has the ability to handle the increased load. So let's simplify this. So let's say you are running an e-commerce platform and there is a huge Black Friday sales coming, and you know your usage gonna go through the roof, like 10,000 plus users. So what you're gonna do is like you are planning for that particular event and trying to add more resources and add some fail-safe mechanism to make sure that Black Friday sales happens without a hiccup. All right. But the problem is with that approach is like once the Black Friday sales is done, the usage limit is dropping back to 100 users or 200 users. But we have to pay still for that particular infrastructure throughout the year. So as a cost for a business, it's not a good approach. That's why elasticity comes in. Elasticity is like we are architecturing a system or an application in order to adapt to workload changes. So it will automatically scale up if needed. And if the usage is going down, it's going to automatically scale down. There is a perfect example for this is Ticketmaster. So Ticketmaster is using this elasticity in a good advantage because they have been using AWS Lambda and SQS to make sure like if there is a huge peak in the ticket sales, it's going to scale up. But then it's going to scale down when the usage come back to normal. So that's why we need to have an understanding about scalability and elasticity. So when we talk about elasticity, there is a one particular very famous service in AWS which can go from 0 instance to 1,000 instances in matter of seconds. Can somebody put some answers about that? So initially, if there is no usage, it will hit idle, like 0 instances. And if you have 1,000 users, it will go to, yeah, Kubernetes is one thing. Yeah, Elasticity is used in Kubernetes. But Kubernetes is not like directly approached in the AWS. There is some services called EKS, which use Kubernetes. There is another, yeah, exactly EKS. And there is another very famous service which can like drop down to 0 and without any like, when it comes to EKS, there are like several configurations to be done. But there is a very famous service without any configuration Yeah, ECS is another service. Uh, can go 0 to 1,000 instances. Uh, yeah, those two answers are actually correct, like EKS and ECS as well. But there is a very famous one that is AWS Lambda without any like configurations or anything like that out of the box. It's provide that scalability to go to 0 to 1,000 in a matter of seconds. So let's talk about Lambda in afterwards as well. So let's move to next slide. All right. So now we are going to talk about AWS architecture in action and the blueprints that has been battle tested and has been used by industry giants. So when it comes to AWS services, there are 200 plus AWS services. And the fun fact is, nobody knows all of it. Even the tech leads or the DevOps engineers or the guys have been using AWS for 15 plus years. They also don't know about every singular AWS service. So when it comes to like architecturing a solution, how we can like get the best services for our application. There's a simple way to do that. So AWS services can be categorized or layered into different categories. There is computing, storage, database, networking, integration, and management. So these are the like basic pillars in AWS service category. So when we want to build a scalable and proper solution with utilizing AWS, what we need to do is like we need to take a look at the categories, those building blocks. So when it comes to computing, there are like several approaches we can take. There are EC2 instances, Lambda, ECS, EKS, Fargate, and so on. Storage, database, networking. Same goes for all of those categories. There are several options for each categories. So when it comes to a problem, so when we are trying to solve a problem, what we need to look at is like what are the service categories we need to use in order to make sure this problem has been solved. And also by using those categories, there are several options. So we need to take out each of these options and take the advantages, disadvantages, and strength into consideration in order to make the perfect solution. So rather than focusing on individual services, focus on service categories or layers of AWS in order to make sure you are building a good architecture. Other than that, so most common mistake most of the guys are making is like they are focusing on individual services. Like some of them are building all the solution with Lambda functions. Some of them are using S3 for all the storage needs. But that's not a good approach because there are several options. That might be the most familiarized option for themselves, but when we take a look at the problems, there might be a better solution out there with AWS services. So rather than focusing on individual AWS services, you need to focus on layers and identify what is the best solution for this scenario and grow from here. Yeah. And then uh, yeah, and then there's another question. So I mentioned that there are like 200 plus AWS services. So with all these service categories and all that, there is a huge chance we can mess up an architecture. So how we can avoid that? What are the precautions we can get to avoid? Yeah. So AWS, the company itself has identified this issue because with so much vast number of services and so much options, there is a very good chance we are like architecting the wrong solution. So in order to make sure not that happening, there is a framework uh, called AWS Well Architected Framework. So this has been presented from AWS itself. So if you are building an efficient, very good system, so these six things need to be satisfied. First one is operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. What do you mean by operational excellence? Even though you have a very good architecture, all the deployment need to be done in a manual way. All the maintenance need to be done in a manual way. All the monitoring need to be done in a manual way. It's going to be operational heavy because you need to put a lot of hours to do that. You need no, you need to allocate and developer to do that. You need to allocate and maintenance engineer to constantly do the maintenance and all that. But with operational excellence, what they have been accept is like you have to automate some of them. Like if you can automate that, automate it. That's the operational excellence part of the architecture. And then the security. The good thing is AWS always has been built with security in mind. But even with that, we need to have additional security precautions in order to make sure our application is secure. And then reliability. So again, AWS has redundancy, like they are when we are deploying an application, it has been replicated over multiple availability zones. So it is reliable. But even though we have to have fail-safe mechanism into that. If this service go wrong, what happened? So we need to think about that. And that's what makes a reliable system. And finally, the performance efficiency. So this is particularly needed for software engineers rather than DevOps engineers. Because when we are like using an AWS services, rather than just putting a code into whatever services we have been using, we need to like build that code in a way to optimize that resource. So let's say you are using AWS Lambda. So you are facing a hard limitation of 15 minutes execution time. So even the code is successfully ran or not, it's going to be run out of time after 15 minutes. So you need to construct the code in a way to run within 15 minutes. So you have to understand those limitations. And that's what I mean by performance efficiency. You need to efficiently run code in that particular services. And especially when it comes to serverless functions, you need to like minimize the usage of third-party libraries because those third-party libraries gonna cost the computing time. And finally, cost optimization. This is another very important part. Even though you have the most efficient and like scalable system in the world, it doesn't matter for a business. When it comes to an industry, you are dealing with a particular clientele. So you need to have an understanding about their business growth and their business investment category because if you are using a perfect architecture and the cost of that architecture end of the month it's gonna cost like $10,000. It's gonna have to be burden for that particular company. So you need to understand that. So you need to read that as well into your architecture. And finally, sustainability. So this is a new pillar. So this what it, basically means is like our architectures have a minimal uh, carbon footprint for the environment. But basically, if we are following operational excellence and performance efficiency uh, as a good practice, the sustainability itself happens. So these six pillars is like benchmark to identify a good architecture, and it has been presented by AWS themselves. Yeah. So let's move to common architecture pattern. So I think most of you guys have been heard about this. There are serverless web applications, uh, CloudFront, API Gateway, Lambda, DynamoDB. So this is like very common pattern in the AWS. And then there is event-driven processing. And then there is data processing pipelines. So let's talk about actual implementation of each of these architectural patterns. So let's say you are like building a simple e-commerce platform and you need somewhere to host your website and you need some server to run to do some basic front operations. Serverless web application is a great way to do that. So CloudFront, we can host the web app with an S3 and link to a CloudFront in order to make sure it works across the board. And then we can have an API gateway linked to a Lambda to DynamoDB to do the backend server part. So it will like if you do not have any customers, it will cost you nothing uh, to keep the serverless web application in the cloud. But if we have thousand users, million users, it'll automatically scale up and handle those scenarios as well. And let's talk about event-driven processing as well. Let's say you are building a like let's say social media application for an example. And you need to once you upload a post, a photo, you need to send notification to all tagged users or something like that. So in order to do that, what we can use is like rather than doing all of them in the back end, we can build up something event driven. So once the photo is uploaded to S3, we can trigger a Lambda function from there as an event. And from there, we can do some processing and using SQSs, SNSs to send those notifications across the board. So that's, I think, you can currently identify in Instagram as well. So if you get some likes, sometimes you notice like in your application, like in the phone, you are getting the notification someone has liked you. But when you go to the post, you cannot see the like itself. Like it's gonna take time, sometimes 20 minutes, 10 minutes. Even though you have refreshed, it's not like instantly showing that in the post itself. Why is that happening? Because they have been using event-driven processing rather than sending an API call and getting response back. They are using event-driven processing. So the benchmark of that is like it's going to take time, and it is called eventual consistency. And then we have data processing pipelines. So data processing pipelines means, let's say you need to do some Viva analytics. Let's get for an example, Netflix. So you need to do some Viva analytics. In order to do that, you can build a data processing pipeline. You can collect the user data from the application itself and put to a service something like Kinesis, which is a batch processing service, and then to a Lambda and S3 and the Athena. Athena is another database service we have. So yeah, those kind of things you can follow. These are very common architecture patterns in AWS. All right. All right. Let's move to a real time, like real case study, like how AWS has been helps to companies scale without crashing. So, uh, have you guys know about the Ticketmaster crash? So, if you guys know about it, please put a message on the chat or that Q&A channel. Yeah. So what happened here is Ticketmaster has started selling Taylor Swift concert tickets, and 14 million people at once try to purchase those tickets as soon as it launched. And what it has been caused is like it has caused the system to crash itself. So that's a very common scenario in these kind of situations. So how Ticketmaster has been identified those problems lately. So let's go to next slide and find out. So the problem they had is like 14 million fans try to buy tickets at the same time. So the system itself need to cater to 14 million users at once. At the time, they didn't have automatic scaling in place. So what was the solution nowadays for Ticketmaster? So they have been migrated to AWS and implemented auto scaling and EventBridge plus SQS and DynamoDB. So auto scaling means like it can scale up and down at bit, like according to the usage. And what is meant by event bridge and SQS? These are like notification services, notification queues. So these queues are like shock absorbers in a car. So if you hit a bump, it's gonna absorb the shock, right? So that particular thing happens when we are using event bridge and SQS. If there is a huge spike coming with the usage, what it's going to do is like instead of processing all of them at once, it's going to stack up in the queue and give the system a phase that can handle by the system. And also DynamoDB. DynamoDB again, it's a serverless approach. So it can virtually unlimited scalability. So it's a very good system to handle these kind of scenarios. All right, right. Finally, we're going to move to cost optimization. So as I mentioned before, cost optimization is another very critical thing we need to think about. Otherwise, even though you have built a very good system and a very good architecture, probabilities the companies and the industry will not use that because simply the cost is too high for them. So yeah, let's move on to cost optimization. And When it comes to cost optimization, there are basically five things need to be considered. First one is right size. So we need to match resource to the workload. We need so even the like we are predicting a massive workload, we need to compare that with cost and get the right sizing and increasing elasticity. As I mentioned before, like only not only scaling up but scaling down when possible. It's a huge plus mark for a good architecture. And then leveraging the right price model. So there are several price models in AWS: on demand, reserved, and spot. So according to different scenarios, we can use different kind of pricing model in order to make sure our cost is optimized. And optimizing storage again, S3 lifecycle policies and intelligent tiering. That's also a huge factor, especially when it comes to large scale applications. Netflix has been moving there like some of these TV series and movies are not much trending, right? So they are moving those to S3 glaciers. So which will cost like cut their cost hugely. So that kind of thing we can apply to our scenarios as well. And no matter how much you have take those precautions and build the very optimized architecture, you should always measure, monitor, and improve. So this is a must when it comes to any architecture. You should have a measuring technique, monitoring technique, and you always have a ability to improve that system as well. So in order to do that, we have tools like CloudDots and Cost Explorer in AWS. Yeah. So uh, like summarizing all that, we can have like simple scenarios and generally have some of the best options we can use like in the industry. If you are like trying to solve a simple problem, there are like battle tested systems you can use. Let's say you have an API endpoint with a variable traffic. Uh, Yeah. Are there any clear benefits of using AWS over other services like Azure? No, there are no clear benefits. So anything you have doing with AWS, you can do with Azure as well most of the time. There are some specific services like, let's say you want to use latest Anthropic AI models. All right. So AWS heavily invested in Anthropic models. So if we are using Claude or something like that, Sonnet 3.5 or something like that in your application, it is best to go with AWS because they have been utilized to do that. So those kind of things we can consider. And another thing is that most of the companies are using AWS because AWS out of the major three cloud providers, GCP, Azure, and AWS, AWS has the most market share, around 32% or something like that. So that's something to consider as well. But other than that, like there are like we cannot put clear benefits for AWS over Azure. I think I have answered that. Yeah. So when it comes to choosing the stacks, uh, if you have an API endpoint with a variable traffic, let's say you are building an e-commerce simple e-commerce system, so you have a variable traffic, right? When it comes, yeah. Yeah. So I have another question, so we'll come back to later. So for that we can deploy that using Lambda plus API gateway. And then we have if kind of a paper request, something like that, like a subscription handling something or something like that, we can use Event Bridge plus Lambda. And for web applications, I think this answers that question. We can use S3 CloudFront plus Lambda. So if you want to deploy a website in the AWS, this is the best way to do it. Like if it is a static website, just an S3, upload the code there, link that to CloudFront. And if you are a domain, link that to Route 53, and that will be that. So it's relatively easy. And also you have AWS free tier. So and it is more than enough to like conduct simple application deployments and so on. Is this correct? Instead of easy to using, Lambda is cost effective most of the time. Yes. Uh, the reason for that is like recently AWS has conducted the research, and what they have say is like over 92% of the EC2s has been deployed in the AWS. Only 20% of computational power has been utilized. So all those money you have been putting into that EC2 is going to waste. Uh, if you can utilize the Lambda properly, it's going to be very cost effective because you pay as you go, right? So you are like paying for the computational minutes, and it's going to be very cost effective. Yeah. And so the web application, we can use S3, CloudFront plus Lambda. And if you are using heavy computation, we can use Fargate or Lambda as well. All right. All right. Let's like try to build some university event type as an architecture challenge. So what I'm proposing is like if your university having some kind of an event, let's say a musical concert or anything, you need to have some kind of events put into an app and distributed across the students. So how we can architect this kind of scenario very simply in AWS. Let's think about that. So for this, I'll need your help. So let's go to draw.io and try to build a simple solution. So yeah, you can unmute yourself and uh, talk with me or put a message in Slack as well. Yeah. What are some common mistakes companies make trying to upgrade? Yeah, we can answer that in the Q&A session, I think. So I would like some answers for this particular scenario. So if you are building an application uh, for your university for conduct events and so on, so how we can start building that? Best if you can participate this one. I think that would be very effective. All right, we have a couple of answers, right? Think about the data we store, DB architecture. Yeah, that's an interesting approach. And first, yeah, VPC. Interesting. Yeah, we can use a VPC for security as well. And yeah, DB architecture is kind of a separate thing. So when it comes to DB architecture, it's on the application level. So we are purely talk about here is the infrastructure level of the application rather than the coding and the inside of the application. So let's come a bit higher to that, like nothing with the DB architecture. Let's come to the infrastructure level. In order to like create the database, you first have to have an infrastructure, right? So let's come to that level. And yeah, VPC again, good thought. Yeah, we can start with the VPC for the sake of simplicity. Let's not implement a specific VPC. So basically, in the AWS, all the services are naturally comes under default VPC. So let's use that one for this. So any more questions? Sorry, any more answers? All right. So how you have come across a problem, sir, right? So how you can approach that? There is a one particular thing you need to understand. So this is for like publishing events, right? So the user is going to spike up and down. So in that case, using a dedicated server is going to have a base because only time the user is going to use it when we publish a new event or there is some kind of tickets for new events and so on. So what will be the yeah, yeah, that's good. That's good. Yeah, we can use Lambda and SQS. All right, let's put a Lambda and a SQS. All right, we have Lambda and SQS. All right. So we have two services here. What else? So we have a client application, right? So let's say it's a mobile application or something like that. All right, we have a client. Uh, so it's in a separate concern. So Let's consider about the architecture in the backend servers. So we have an SQS and a Lambda function. So what else we can use in order to make sure like this communicate with the Lambda function? What we can use in between the Lambda function and the client? Yeah, there's a service called API Gateway. There's a service called API Gateway. So what this basically does like this is some kind of like a REST API gateway or something like that. And there is a client, and we can connect that to an API gateway. So in between that API gateway and Lambda, we can put a SQS as well. That's a good approach. So then we can accommodate like spikes of the application. But if we put an SQS, what happened is like this is happened to be a asynchronous process. So that's something we do not want. So in order to make sure that doesn't happen, with the API gateway, we can directly trigger the Lambda function, right? And then to upload some kind of a image or something like that, we can use S3 buckets. And we can direct that direct to the Lambda function as well in order to upload some images, videos related to events as well. And then, so again, this is very basic. So we have an API gateway, Lambda function, S3, and we need a database in order to do that. There are like several ways to do that. There are RDS. If you want to create a relational database, we can use RDS for that. If you want like document databases, we can use DynamoDB. So DynamoDB works particularly well with Lambda. So in that case, we will put a DynamoDB in here. So we have a DynamoDB connected to an AWS. We have an S3, and let's say we want to have like scheduled messages. Let's say when the event comes to close, we need to some particular messages or something like that to the user. How we can do that? We can use event bridge in order to do that. We can have event triggers. Yeah, we can have time-based event here, and it can be linked to Lambda as well. So again, this is a very simple architecture using AWS. And as you mentioned, Dindu, yeah, we can add a VPC in order to make sure this everything has been secure as well. Yeah. So if you want to build a simple application, so this is a very good starting point. So this is how you like thought about the application. Don't overcomplicate things. Like if you have like several services, identify the scenarios and identify what would be the most effective and most simple solution to do that first, and build up from there. So don't overcomplicate or over-engineer architectures. That's the most common mistakes most of the engineers do. They are trying to cater for the problems not yet occur, right? That is part of over engineering. So don't fall into that trap. uh, so use something like this, like build simple, and yeah, use AWS to solve your problems and build awesome applications. Even it is small or very complex, AWS has the capability to do that. And the most awesome thing is if your application grow into global level, you don't need to change infrastructures with this. So you can use the same infrastructure in order to cater to that. The perfect example is Airbnb. Airbnb has been started as a very small company, but they have been utilizing AWS. So when they have become a global hit, it was really easy for them to scale up to that level. Yeah, so this is how like we architect the small problem using the AWS as well. All right, and yeah, let's open for Q&A. All right, I think I do have one question here. What are some common mistakes companies make when trying to optimize AWS cost. Yeah, first, first mistake is they are not monitoring. So that happens all the times, even with all the engineers and the all the safety security mechanism in place. First things happen is you don't monitor the system. So cost can grow over the time. So you need to monitor the system. You have to put a mechanism there. You can put like cost analyzing. You can put budgets in the AWS. That's something we can do. And when it comes to the optimization, most of the time, like we are you using unwanted computational powers and unwanted storage options. And also, databases can be very expensive in the AWS. So you need to find out the ideal database solution for you. So if it is like too expensive with the AWS, you can move out. Like you can use MongoDB Atlas. There are several other very good database systems as well. So you can use them as well. If used correctly, it will be awesome. But if you are not monitoring and you are not properly um, implementing those fail safes, it can be disaster. Yeah. Any more questions? Yeah. How to think when to use EKS and ECS? It's relatively simple. So let's say you need a really heavy computational power, right? So your application it's a very computational heavy and like it'll need a longer time to process. That's when we are using EKS and ECS. So basically, you are utilizing Kubernetes powers and those clusters in order to make sure everything works. So that's when to use EKS and ECS. And there's another a very particular usage to this. So if you want to like implement a legacy system into the AWS, like you want to migrate a legacy system into the AWS, most of the times we can use EKS as well because it's a managed service. So we can customize our clusters and the uh, process as well. I think they're gonna upload, right? I'm not sure about that. Yeah. So can AI/ML be used to forecast cost trends and optimize AWS expenses? Yeah, that's a very good approach. I think, yeah, theoretically it can be done, but you need like specific set of data in order to train that thing. So you can use that using the AWS as well. So AWS providing some service called Bedrock. So for custom AI training and so on. So if you can find some good data sets, yeah, I think that can be done. So I haven't come across such thing, but I think I can be done. So AWS itself has a AI agent right now called Q. So yeah, I think industry heading that way. Yeah. All right. Any more questions, guys? All right. All right. I think we do have one. All right. If we develop a backend and deploy it also. No, we do not need to implement code to handle the traffic in the backend source code. That's the awesome thing. Uh, if we are deploying into Lambda or something like that, you basically need zero configuration to like scaling up and scaling down. Only thing is like your code need to be optimized. So it need to be do whatever it does within 15 minutes for one invocation. So let's say you are like creating some kind of like a product or something like that, product operation or something like that, it need to happen within 15 minutes. Then that's the only limitations. Other than that, we don't need implement like code to handle those traffic. Yeah, so far it works here. I'm not that much familiar with Firebase services, but it is very similar to AWS Lambda as well. Uh, yeah. So what are the new features will I get if I switch to Lambda AWS? I'm not sure about that. You need to conduct a research on that, like what are comparing the Firebase services and AWS Lambdas. So if that execution time is higher than Firebase services, that could be an good thing. And also you need to keep in mind about the cost as well. So you need to do a cost analysis between those two and try to make sure what is the best approach for you as well. Yeah, other than that, yeah. Right. So if you develop a website, right? Or, all right. So there is a service called Amplify, and there are a lot of tutorials in order to do that. So if you are using Amplify, so if you are using a website using React or Next or anything like that, AWS Amplify is a perfect way to deploy your code. It's very minimum configurations, and they are handling the load for us, and they are like utilizing the CDNs as well. So that's a good place to start. So you can go to AWS services and search about AWS Amplify. That's a good way to do that. If you are using a WordPress or something like that, you can use Lightsail in order to do that. So again, there are like couple of options to do that. So first you need to do some research about like based on your requirement, what are the technologies you are using and what is the best way to deploy that. So the initial steps is like from Amplify, it's pretty simple. You can go to Cloud Console. You need to have an AWS account. Go to Cloud Console, search Amplify, and there you can create an Amplify instance and deploy the code from there as zip file or something like that. So this is the official documentation for that. I think you can get some references from here. And if you are using WordPress or something like that, this is a good place to start as well. Yeah, if you move to the AWS, you will need to pay after the free trial. Yeah, so you need to pay after the free trial, but the most of the services have free limit, like for a month. So I'm not sure about the exact numbers, but let's consider Lambda or something like that. Even after the free trial ends, there is a particular limit per month which we can use without any cost. Most of the services have this limit. And also, there is a program called AWS Credit Program. So if you are like, let's say you are starting a startup or something like that, what you have basically do is like you are proposing to AWS, we are a startup. And we are trying to use these kind of user services in our applications and we need some credit, so they'll provide some credits like $1,000 per month or something like that. So that credit limit we can utilize. So that's a very good approach if you are like trying to implement a new application, cost heavy application, or you are trying to start a startup or something like that. You can apply for AWS credit program. Yeah, that's another thing. So always destroy your services you used. But the interesting thing is with some services like EC2, even though you have deleted the EC2 instance, there is something called EVS. The volume itself, it remains, and they're gonna cost you for that. So you need to be really careful about that. And when you are like deleting a service, go through some documentation first, and go through some documentation and try to understand how to properly delete it. After understanding that, you can delete it properly. Otherwise, if you are using EC2 something like that, even the instance itself has been deleted, there are some other services remains. All right, I think we have used all the time we have been allocated. So if you have any more questions, I can bring. Yeah. Do AWS has cost review limits for their services? Yeah, they do have. For every month, they do have a cost review limit for their services, and you can utilize AWS free time as well. And also there is AWS credit program. So if you can like submit a proper proposal kind of thing to AWS, they'll go through it and they'll approve it. Yeah. So when you guys like walk into the industry, it's a really good asset to have AWS in hand, because most of the companies and most of the clients have been using AWS over and over. Same goes with Azure and GCP, but AWS is a really good asset to have have the ability to build applications and some kind of understanding of. And one thing we didn't talk about in this session is infrastructure as a code. So that's something you need to understand, and it's a really awesome thing to do. Rather than go to the AWS console and creating all those things manually, you can build this as a code and manage it as a stack. So that's something I would encourage you to see at as well. All right. If you don't have any more questions, I think we can wrap up this session, guys. Yeah.
Thank you all for your fantastic questions and participation. I think we covered a lot of great insights today. A massive thank you to Diliru Munasingha for sharing his incredible expertise on AWS architecture with us. Your insights have truly helped us understand the core principles of building scalable and efficient cloud solutions. And of course, a big thank you to everyone who joined us and contributed to making this session so engaging. Before we wrap up, just a quick reminder, stay connected with the FOSS community, the University of Kelaniya, for more tech driven events and workshops. Follow us on social media for updates. Our feedback from will be shared shortly. Your input helps us improve and continue bringing you valuable content. Once again, thank you for being part of today's session. Have a wonderful evening. Stay curious, keep innovating, and see you at the next event.